And let me maximize the chat. Okay. So in today's lab, we are finally going to start doing JavaScript. And so what I opted to do with this lab, since this is our introduction to JavaScript, and since this is effectively a senior level computer science class, I'm going to take the assumption that everyone knows how to program in another programming language pretty well. And I'm assuming the language that everyone knows pretty well is Java, because everyone should have taken Java in 1583 and 2120. So I'm not sure if anyone here has gone through this project, but one of the things we're now doing at the tail end of 1583 is we're building a full graphics-based platformer video game for 1583, just to show how object-oriented programming can be used with polymorphism and with inheritance and all the other great things that we learned how to do in Java. Well, I decided to convert that project that we do at the very end of 1583 into a JavaScript project and use it as a lab. So effectively, this lab should be able to cover all the remedial concepts of basic JavaScript. It should show us all of the built-in JavaScript data structures that we'll have available and accessible to us. And it'll show us how we can use JavaScript in a very Java-like way, how we can use JavaScript to actually define class hierarchy and use inheritance to build a sophisticated application. So whereas the other applications were a little bit slimmer in scale, this will be a full application. We'll likely take a couple of different lecture labs, a lot of these video labs, to be able to work through it. But by the completion of this, we shall have a very strong understanding of JavaScript from the very basics to the very object-orientedness that has been added to it. So I'm going to come back to this table of contents, but a little pre-warning, this is by far the biggest lab we're going to cover, and it's meant to be the capstone object-oriented project from 1583. So the goal here is by the time we're done this lab, you will know JavaScript as well as you know Java. That's my goal. And again, if you have any questions while I'm going through the lab, please just go ahead and put it in the chat, because I observe the chat while we go through these stages. So I'm going to go through the goals in a moment, but I want to get more through just the lab introduction. So I'm going to come back up to this page. So the prereqs for this lab, well, clearly you have to have a little bit of knowledge of object-oriented programming, because I take it for granted you understand what the concepts of classes and inheritance and polymorphism and instance variables and instance methods and things like that are. Our software requirements are going to remain the same. We just need a Chrome browser or any browser, but I'm going to use Chrome, and I'll only answer questions related to Chrome browsers if you have any technical issues while you're developing this. And of course, any code editor or IDE to actually author up your HTML and JavaScript code. The motivation behind this particular lab is we want to learn to use modern JavaScript to design a browser app using an object-oriented architecture. And then our goal, the actual thing we're building, is going to be a platformer game that runs in the browser, and it's going to use JavaScript, pure JavaScript, and it's going to use the Canvas API. So what is the Canvas API? Well, if you ever have any questions, we can always go, oh, no, that's not quite right. Canvas API, MDN, the Mozilla Developers Network. We can see here the Canvas API provides a means for drawing graphics via JavaScript and HTML. So it essentially gives us a canvas that we can send data to and produce game graphics or animations or data visualizations or photo manipulations or any kind of real-time video processing. Okay. So the learning objectives we're going to have for this lab, we want to learn our JavaScript basics. We're going to learn how to do objects and classes in JavaScript. We're going to learn about inheritance and polymorphism in JavaScript. We're going to learn how to apply the various data structures that are existent and defined in JavaScript to build out the specifications of our application. We'll look at the Canvas API for having a drawable viewport and user inputs. And then we'll also learn the basics of how to design and implement a browser app from the initial planning stages to the complete deployment phase. So we'll walk through every facet of developing a platform game and a real application. So our project architecture for this lab, we're going to start by downloading our starter files from GitHub, just like we have before. But the general idea is we'll have this platformer directory. Inside the platformer directory, we'll have our HTML file. That'll be our initial launch point of our JavaScript application. So recall, we can't open up a JS file directly from the browser. It always has to be imported by an HTML file. So this will be effectively our main method of sorts, our launch point. We'll have our assets directory. It's going to have all of our images and everything else that we need. And then we'll have a scripts directory, which is where we're going to put all of our JS files. So all of our external JavaScript files that we'll make will go in here. So let's start by actually downloading this. I guess I could just do it here. Excellent. Okay. So let's go ahead and get this pulled into there. Let's unzip it. Okay, that's unzipped. Delete that. Don't need that anymore. And I'm going to rename this for consistency platformer. Okay. And as I can see, I initially have all of my assets. It looks like background images and artwork. That's clearly like not mine. And some other tiles that we'll use in the course of building up this game. Scripts, there's only one thing in the scripts. It's scripts.js, and we'll take a look at what this is in a moment. But I'll open it here. So no, actually, let's do that again. There we go. Okay, we'll look at that in a moment. And that's it. Okay, perfect. So let's go through some concepts now. First, the JavaScript programming language. So what we've seen before this class was HTML, which is a markup language. It's a declarative language. We've seen CSS. That's a styling language. So here, JavaScript is a programming language. And we've used a little bit of JavaScript previously. Let's see here. Okay, perfect. Nope, don't want that. Perfect. Okay, so we've seen JavaScript previously with some embedded JavaScript for our first homework and for first lab. But here we're going to start removing it from the script tags from HTML and putting it in its own JS file where it belongs. So what are some facts about JavaScript? Well, first of all, all web browsers include a built-in JavaScript interpreter capable of both general purpose computations and domain-specific processing. So by general purpose computations, I mean, we can use JavaScript now to build any kind of application similar to what you can do with Java or Python. But not just that, you have to understand JavaScript started out as a domain-specific programming language for managing HTML elements. So a lot of view-based stuff is handled by JavaScript. In fact, that's what it's really good at. So JavaScript actually supports a multitude of paradigms: imperative, procedural, object-oriented, and functional. So just to give you an idea of what that means, and again, these concepts, the value these concepts have to us is how can we author JavaScript code? So imperative just means that JavaScript code may be defined and executed statement by statement. That means I don't have to put my code in classes or in methods or in functions or in anything for it to actually execute. I could just put console.log hello world and it'll work. And so languages that support that capability, oh my, it's really cluttered in here. So for instance, I can do console.log hello world, and I can just do that. I don't have to have any kind of boilerplate structures to manage that for me. So procedural means that I can also have my JavaScript code organized and defined within functions. Object-orientedness, which it says components, but that should say object-oriented, means I can define my JavaScript in terms of objects and classes. And then functional means that I can have my JavaScript code organized as a set of cascading function calls. And here the distinction between functional programming is that I aim for as much of a stateless system as possible. So with objects and classes, we manage state encapsulated inside of the instance themselves. In a functional programming paradigm, I try to limit that. So if you haven't seen all these different paradigms, you will see these in programming language structures. So this class will actually give you an opportunity to play around using one language with 4 different paradigms. Now, in addition to that, when using JavaScript, we are going to link all of our JavaScript files into the HTML document using a script element. We've seen that before a little bit in the first lab. So in our head, we can link the JS file to the head if it has no dependencies in the body. So we preference using the head, but recall, if your JavaScript is trying to access something that's defined in the body of the HTML, then we also have to put it in the HTML. Because now there's a dependency, an HTML element dependency that exists where it's going to have to access it. Now, the Canvas API, I just showed you this on the web page not too long ago. Browsers provide a JavaScript-enabled viewport called the HTML Canvas element, and this element supports real-time 2D or 3D graphics. It also allows you to capture user input on that canvas and update the canvas as necessary. So when we think about this, and you've probably covered this as a design pattern, probably in 2120, when you start building out event-driven graphics-based applications, you can think of it as a model view controller layout, where the model is going to be where all of your data resides and all of your logic resides. The view is going to be the canvas that provides our real-time rendering of our computer graphics and GUI elements. And then our controls are going to be provided by some kind of built-in API for capturing user events from the input, either the keyboard or the mouse or whatnot, and then importing that into our model that's going to respond to those controls, and then it's going to output some results into the view or the canvas where the user can then see it. So we will be adhering to a model view controller design pattern when we build out this application. Okay, so examples of our browser-based game. Well, there's several examples of browser games that exist online, but there's one that's built right in the Chrome browser. It's the Dino game. So actually, if I let me see if I can just open up this link. Or what I'll do here, if I just do about:dino, I'm sure everyone has seen this before, right? The Dino game, that's whenever you don't have internet, you can just hit like the space key and, oh yeah, I'm not very good at this game. Okay, enough of this though. So this is an example of a simple Canvas game. Okay, so let's go to goal 0, which is really going to focus in on the design of our application as a whole. So again, the purpose of this lab is for an object-oriented programming designed in JavaScript. So our first approach is to figure out our game objective. In this lab, we'll build a platformer game. The player must jump on blocks to navigate the exit. The player must avoid floors and ceiling hazards to prevent a game over state. And if the player gets to the exit, then another stage will load until the player exits the last stage and wins. The player is affected by gravity and friction. The game is designed using inheritance and polymorphism to store common data for each type of related object. Okay, so everything you would traditionally think of in a platformer game, that's our game objective. And I don't know if I actually have I'm not even going to bother showing you a demo of this game. I don't want to waste the time for that. We'll just see this game evolve as we develop it. So our application, our do phase for the planning portion, the design portion of this application. Well, the first thing we need to do is we have to define our game objects, right? Whenever we start planning out an object-oriented program, we know it's going to be so complex that we're going to have multiple entities that exist in our application, multiple objects, and we want to start planning those ahead of time. We want to start thinking about, well, what is a platformer game going to need before I start doing any coding? Even if I'm doing iterative design, it's a good idea to start thinking, well, what are the game objects I need? So from the player's perspective, the game objects that we'll need is a player character. And so some of the roles that the player character is going to have to do in our application is, well, it's going to have to be able to move left. It's going to have to be able to move right. It's going to have to be able to jump up. And other things that the player character we should be aware of is the fact that it's going to be affected by physics and gravity, as well as friction. So we'll define physics in our world, in our game world, as just having something to do with gravity and friction. Then we'll also have brick blocks. So this game object is one that the player can collide with and cannot move through. And these types of blocks we can then use to build our floors, our walls, our ceilings, and whatever platforms we want. Then we can have hazards. We might have two types of hazards. And when we think of a hazard, we can think of it as a special type of block. So a ceiling hazard, for instance, the player might die if they collide with a spike that if they jump on top of from underneath it. And we might have another type of hazard, which is a floor hazard, that if the player lands on top of it, they might die. And then we'll have an exit, which is also a different type of block, but is one that will allow us, the player, to advance to the next stage. Okay, so let's take a quick overview of some of the classes then. So now that we know some of the game objects that we all have to consider from the player's perspective, let's look at some of the classes we might need from a game management, from an application perspective. So we'll have a game class, and the game class's role will be to manage the game data and game methods. We'll have a world class, and the world class will manage all level setup data. We'll have a scene class, and the scene class will manage scene data and scene methods. So a world might be defined as being a collection of scenes, and a scene is something that you actually contains all of the game objects. We'll have a block class, which will extend a game object to define a block. So let's jump over here. Game object. What's a game object? It manages all common data for game objects. So a block will extend a game object, so a more specific game object. We'll have an exit, which will extend a block. We'll have a ceiling hazard, which will extend a block. We'll have a floor hazard, which will extend a block. Oh, yeah. Is that better? Let's see. We know the game object will probably be kind of the parent class of all entities that exist in our game. We'll have a player, which will be a specific type of game object. We'll have, besides, okay, so these between player, floor hazard, ceiling hazard, exit, and block, that probably defines most of our game objects. We also have to have a controller class, which will manage the player inputs to move a player. We'll have a standard draw class, which will essentially be our library class for drawing graphics. So I don't think we'll have that here. I think we'll use the canvas element, but we'll see. That might be a remnant of the Java use case of this, so that might have to get next. We'll have a physics class, which is going to manage the physics, the gravity, the friction, and the velocity. So all of the interactions of the player in our real world like environment. Then we'll have an animation class, which will manage which image is to be displayed at any given time during our game loop. And then we'll have a pose class, which will contain all possible animated poses. So when we kind of sit down and break apart what we might have to define responsibilities across a platformer game, this is probably going to be the list we come up with. Our standard draw might be just the Canvas API here, if it's not called standard draw. So it's still a responsibility of our OOP application. And then we're going to have this configuration file here, the world data.js. And we get this is given to us as part of this assignment. So what we're going to see with the data that's going to be contained in here, and let's take a look at it here. Let's actually look at this. So we're going to have world. This is essentially what's happening here is we're declaring a global variable because we haven't given it a context of var, lit, or const. So we have a global variable here, and we're assigning it a empty array. And in JavaScript, arrays are dynamic. So they can grow in size as we assign things into them. So they operate very similar to Python-styled arrays and less similar to Java styled arrays that are static and set in size. So once we have our array declared here, we can say, well, at index 0 of array, I will then assign, I do an assignment operator, and then I'm using, if you see this is a tick. So this is like the tilde key that's been shifted. So that creates a string template. And I go into much more detail about what string templates are if you watch the lecture video. But one special thing that string templates allow me to do that I can't necessarily do with traditional strings that use either the double quotation or the single quotation is that I can actually define it on a separate line, right? Like, so I have this, and usually what I could also do is wrap it in parentheses just to make sure that works. But what this allows me to do is kind of just define my my world data so that it lines up. So I start the string here, I ended the string here, and each one of these characters is going to represent a tile. So say, for instance, the hashtag is going to represent the standard block tile. The V is going to represent a ceiling hazard, and A is going to represent a floor hazard. A @ symbol is going to represent the starting location of our player, and the exclamation mark is going to represent where the exit point is. And so since this is going to be a multi-leveled platformer game, this will represent our first level. And then this inside of index 1 of our world array, we will then have a string that will be able to parse that represents our second level. And then at index 2, we'll have a string that represents our third level. So we have 3 different levels that have essentially been pre-designed for us to go ahead and implement on top of. Excellent. And so going back up to here, so I think that's going to finish up the kind of explanation of what we're building. Let's go back up to the table of contents, where we can kind of get a strong understanding of how we're going to step through this. So starting forward, we went through the learning objectives where we talked about what is JavaScript, Canvas API, SPA. So an SPA is also what's referred to as a single page app. Up until this particular lab, we have worked on multiple page apps. And many years ago, that was the traditional model for building a website, is that you'd have an HTML document for each individual page. But one thing you might have realized working on the first homework was that every time you load from one HTML document to another HTML document, you lose whatever state was being maintained in your JavaScript runtime environment. And since JavaScript has access to the HTML DOM elements in memory, and it can actually update the browser's viewport, it has become shifted in terms of the architecture style of building up an app to be what's called single page. So instead of having multiple HTML pages, you have the one HTML page, and every time you need to update with new information, we can do it via JavaScript, and that allows us to maintain a singular JavaScript runtime environment and have a consistent data state there, so we don't have to do hacky things like using the search parameters to migrate state from one page to the other. Okay, and then in our goal 0, we talked about what is going to be the overall design of our application. We're going heavy, heavy, heavy in the object-oriented design. So the same metaphors and practices you should be very comfortable with coming from Java, we will immediately be able to adhere to and build and structure applications very similar to that in JavaScript. Okay, so the actual application, when it comes to actually building it, we're going to do it iteratively. I feel like every application that one designs should be done in an iterative approach. It's a great way to start with very little and build up the complexity to get something that is complete and finished in a manageable way. And so in order to get this game built, we can break it down into effectively 20 different iterations or 20 different little goals that will build into each other until we're done. And so our first goal will be to make the HTML page. That's going to effectively go ahead and import all of our JavaScript code and allow us to actually start running our JavaScript application. And then the next thing we're going to do will be define each of our classes. And we'll start with the view class so we can start drawing things. And then we'll start with the game class because the game class is going to manage all the rules. That's going to manage all the main game logic we have. Then we're going to create a world class. And again, that's going to be responsible for loading and managing all of the level data. Then we're going to build a scene class, and that's going to be the class that's responsible for managing all the playable game objects in a particular scene. Then we're going to define a game object so that we can contain it within a game scene, right? And so we want to make a game object such that it not only exists inside of our data model, but we can also draw it and view it. Then the next goal will actually build a block, which will inherit from this generic game object. And we want to try to define, so all of our blocks will be managed by the block class. And we'll try to draw all the blocks from the level data that we have. Then we'll create the player class, and that's going to be the class that manages all the player data and draws the player. Then we'll create a physics class, and that's going to be the class that manages all of our physics rules, where we can add gravity and friction and things like that. Then we're going to create a controller class, and that's going to be the class that manages all the player controls, where we can move left, right, and add a jump. And then we'll keep adding things to that. So initially, when we create like the controller class, it might just have the jump option, but then we'll add the ability to go left and right. And we'll add that implementation in a pre-existing class there, controller. And the same thing with physics. We'll start adding collision detection for floor collisions and ceiling collisions and left-right collisions. Then we'll add friction. And then what we'll start doing is we'll start adding new things into our game, like the hazards, so that we can get a death condition into our game. And then we'll add exits into our game so that we can start defining win conditions in our game. And then after we get our game working in kind of like this static, non-animated approach, we're looking to creating an animation class that can update our sprite so it actually is animated. And then once we're done that, we'll see that from scratch, using almost no external modules of code, we will have built a complete game system. And then that'll lead us, when this lab is complete, that'll lead us to the next homework. That would be homework 3, which will be to build your own JavaScript application. Okay, so let's go to goal 1. With goal 1, we just need to make the HTML. So again, every one of my goals, I always like to break it down into a 3-stage process. What is our approach? What is our application? And what is our assessment? So the approach, you could always think of the plan for this goal. The apply, you could think of as the do phase of the goal, the actual applications. And the assess is the testing to make sure that our goal is working the way we expect. I like to call this the AAA approach to software development. Okay, so here, what Canvas is going to be the tool, is going to be the HTML element that we're going to use that allows us to use JavaScript code to draw graphics directly into the browser's viewport. So we're going to have to create an HTML document. We're going to call it platformer.html. So let's do that. Let's go jump over here And let's do touch. Nope. And platformer.html. Perfect. Where am I? Oh, there it is. So let's drag that into here. Okay. Okay, perfect. And let's actually go into my platformer. So the rest of the lab, I'll be in the appropriate directory. Okay, so now let me pull this into my editor. What's going on with my trackpad? Okay, there we go. And also, let's pull this into our, there we go, into our browser so that we can go ahead and monitor what we update over time. Okay, so now that we've created an HTML document, what I'm going to do first is I'm going to grab this HTML code, but then I'm going to step through what's happening with it. So I have our HTML document here. Okay, so let's get rid of, I don't need all this stuff here. I'm going to clear out some of this stuff. So we have our HTML document, and then I'm going to have here the head, and I'm going to have the body, and I'm just going to put some data like we started to do, I think, in our prior lab. Some metadata that the character set that I'm going to use is just UTF-8. Not necessary, but it's good to have. If we don't specify this directly, it'll be embedded there for us. I'll also go ahead and add a title that says platformer. And then inside of the body tag here, I'm going to create that canvas HTML element. I'm going to give it a couple of attributes. I'm going to give it an ID of viewport so I can access it from my JavaScript runtime environment. I'm going to set the width of this canvas element to be 500 pixels, and the height will be 500 pixels. And then I'm going to set the style of this canvas element to go ahead and just have a border of 1 pixel, solid, and black so that we can actually see it. Since we're not drawing anything in it, I want to be able to actually see it. So after I go ahead and add this HTML code, I should now be done this step. I should be able to test. So all I should have to do to test this is open that platformer.html in the browser, and we should see an outline around our viewport. So let me update this, and yeah, there it is. So here is our canvas element. I've drawn the outline around, and yep, I have platformer in my title right there as well. Perfect. Okay, well, with that said, I can go ahead and move to the next goal. The next goal is, well, now we're going to start making some JS code. Everything else from here on out is going to be JS code. So the first JS code that I want to make is going to be a class that's going to be called view. And so the JS class is going to be responsible for calling the browser's Canvas API to render images into the HTML canvas. So to define a view class that represents the game's renderer, we can just go ahead and then draw that. So let me see here. So let me go and make a JS file called view.js. And notice, for instance, here, I'm actually going to use an uppercase for this script name. Now, sometimes I'll use uppercases, sometimes I'll use lower cases. If it's going to be a class, I'm going to use an uppercase. If it does not contain a class, then the JS file name should be lowercase. Now, none of this is enforced. It's just a programming practice. Okay, let me go into my scripts. So change into my scripts. And let me touch into here. What was this? View.js. And here, because this is going to be modeled as a class, I'm going to use an uppercase on there, whereas world data is not. So it's modeled using lowercase. Okay. Let me copy this, and then we will explain everything that's happening inside here. So in order to declare a class, well, you'll see a lot of this syntax is very similar to Java. So classes are defined using the keyword class, and then we give the class a name. And so to be consistent with Java-like notation, we'll use a uppercase letter for our class names, and then our classes have to have a scope. We use curly braces for the scope. Then inside of our class, we can define our instance variables. We want to have our instance variables be private. To define instance variables based on a class scope, we can go ahead and just define them inside of the scope, but we also put a hashtag in front. By putting a hashtag, this is a symbol that JavaScript uses to enforce the private label, the private access type onto these data attributes. So this means that external code will not be able to access either of these properties, canvas or context. And again, we can enforce that by putting the hashtag in front of that. So our class scope ends here. Now, what we'll also do for our game is we're going to actually use our view almost as a singleton type object. So in order to do that, we're going to create a constant variable that'll be managed inside of our view, and we're going to assign it a new instance. So we'll invoke the constructor here, and then we'll bind an instance of a view object into this view variable, which is now, since it's outside of a function, since it's outside of a class, it will be a globally scoped variable that we can then use inside of our application. Okay. Now, the next thing that we're going to want to do, now that we've essentially stubbed out a view class, is to define a constructor for it. And so our constructor should do a similar role as to what a constructor inside of a Java application would do. So I should go into here, into my class scope, and I will define a method called constructor. So just like in Java, your constructor has to have the same name as the class. In JavaScript, your constructor uses the name constructor. I actually like that better because it's more evident as to what that method is doing. Its role is to set up all of the instance variables and to set up an instance of the class. So the method that gets invoked whenever you say new and then invoke the constructor will be the constructor method. And then our constructor method, what we're going to do is we're going to go, hey, we're going to invoke from the document. Hey, document, we want to get an element by its ID. And we want to get the element that has the ID of viewport. So this canvas element here has that ID viewport. Well, I can use the, where'd it go? I can use here the document API to get that element into my JavaScript. Now, I could have just as easily just used viewport as well, because that would have worked. But this is the more robust way of doing that. And again, I explained this concept in the lectures. So when you watch the lectures, you'll the general reason why we prefer this over just using viewport is that I can override the value of viewport in the JavaScript runtime environment, and then I lose value of it inside my application. Whereas if I grab it using this API call, I could never accidentally override it. And then I'm just going to use the constructor to set the canvas attribute and to set the context attribute. So here, I'm going to get that HTML element, and I'm going to bind it here so I have reference to it. And then one of the values that a canvas has is its context. And the context of a canvas element can either be for 2D, for the 2D API, so that we can render 2D graphics, or the 3D context that has a 3D API where I can render 3D graphics. Well, this is going to be a 2D game, so I just want to manage the context because we're going to have to use that for actually being able to draw graphics into it. So there's obviously a different set of API calls, whether we're using a canvas for 2D or 3D graphics. And again, if at any time I don't fully explain what's happening with this code, just go ahead and ask a question in the chat. So the third thing I want to do is define inside my class a picture method. And the picture method is going to be a method we're going to create that's going to allow us to draw an image into our HTML canvas. So now let me go into my view class here, and I'm going to go ahead and create a picture method. The picture method is going to have a number of parameters. It's going to have a image file path. It'll have an X and Y coordinate of where I want to draw that image inside of my canvas element. And then it'll have a width and height of how large we want that image to be. And so in order for this picture to actually get drawn, because again, it's the role of the view class to do all of our graphics drawing, well, understand that Canvas has its underlining API on how we could set images inside of it. We access Canvas's API based off of its context. So remember, one of the first things I did in the constructor was access its context and saved it into a JavaScript variable, into actually an instance variable. And so I'm going to access, every time I want to set a picture into our canvas element, I'm going to access the context that has the API. And one of the API calls that's built into it is a draw image method. And a draw image method requires up to 5 different parameters, which is going to be the image path file name, the X and Y coordinate that the image is going to go to, and the width and the height. So notice this is kind of like just a wrapper method that's going to send the data from that's passed into the picture method, and then send it to the appropriate API call so that we can actually draw that image. And again, if at any time you wanted to see what you could do with a canvas element, you can go to the MDN and in fact see all the different kinds of calls you have available there. Go back here. What was it? What was that call? It was draw image. So for instance, we could do draw image. And we could see all the different documentation for how we can update the canvas. And then all the other different methods that you can use for data visualizations, besides adding an image, like drawing rectangles and circles or arcs or polygons or all sorts of other things. Yeah, so this step, we're eventually going to get to the point where we want to go ahead and effectively draw our map. But we're going to do that in a piecemeal way. We'll find out actually what we want to accomplish in the assessment phase. So in the assessment phase here, we'll want to be able to just test to make sure that we can draw things. So the next thing I'm going to do is inside of our body, now that we have this view.js file, and this view.js file will actually instantiate an instance of view inside of the view variable, which we'll now have available to us at global scope. Let's actually, now that we have this, let's go into our platformer.html, and we actually have to go ahead and add this. And since our script here is accessing something that's defined in the body, then I have to put the script that imports this JS file in the body at the very end, because this has to exist before this can do its thing. Excellent. So now to actually assess this, what we can do is we can open the platformer.html and we can try typing some code and getting our viewport to do something. So let's see here. So here I have some code that it says I can play around with. So let's try to do that. Let's go. And actually, let me get this print out here so I don't have to jump back and forth. Perfect. Okay. So here, if I refresh, I'm still not drawing anything because all I have is that view class. But one cool thing about JavaScript, let me stretch this out a little bit. One cool thing about JavaScript is I can interact with the JavaScript that's preloaded in real time. So if I just type in view, for instance, you'll see, oh, look, that's that variable that holds that view instance. So let's see if I can start sending it some code. So say, for instance, let me make a background variable. And I want that background variable to be essentially a new image, an HTML image object. So look at that. I was able to create an HTML image object from that. And we'll go much more into this ability to dynamically create HTML elements from JavaScript when we get into our lectures about DOM. And that'll be, I think, in the next lab after this one. And then so I'll take my background, right? And so now, since that's an HTML element that's in our JavaScript runtime environment, I can define a source attribute. And say, for instance, the source attribute is going to be inside my assets directory. I have the background of a PNG. So background.png. Okay, so now let me go ahead and set that. And now let's see if I can't say from that view variable, let's access that picture instance method. And remember, the picture instance method required a image. So we'll pass it this background image we made, coordinate. And so the graphics, most graphics applications use the top leftmost coordinate that you want to draw on. So this is going to be the background image. We want it to start at the 0, 0 coordinate, the upper left coordinate. And then our width and height, we want the background to fill the entire thing. So 500 width, 500 height. And if I go ahead and do that, notice, bam, I just interacted with that class instance and we set that image into our canvas. Excellent. So suppose I wanted to draw something else. So let's make, say, for instance, a hero image. So let's do a new hero image, right? And let's say that the hero, let's set the source attribute for our hero to be inside of our assets directory. We will have, let's use a spaceman PNG. So we'll set that as a source, the file path there. And then I'll invoke there's only the one method inside of our viewport, right? It's the picture method. So let's send it our hero image. And here, we're not going to draw this across the entire canvas. We want to make something smaller. So let's say we want to put our hero at the 250 coordinates. So at X coordinate 250, Y coordinates 250. And let's say we want our spaceman to only be 32 pixels by 32 pixels. And then if I do that, you can see I can draw the spaceman right on top. So here you can see our viewport with our picture method seems to be working just fine when we interact with it directly from our console, from our terminal. Okay, perfect. Let me get this back here and I'll collapse that. Okay, so I'm happy with that goal. Our viewport, our view class seems to be working the way I expect it to. So let's move on to the next goal, where we're going to design our game class and start defining our game class. So again, let's break this down into the approach, the apply, and the assess. So in the planning phase for our game class, let's just stipulate that the game class is responsible for managing all of the game data and the game rules. So again, whenever you start defining a class, start by saying what are the properties it has in it and what methods is it going to have to support and who's going to be the client to this class and who's this class going to be a server to. So these are, when designing an object-oriented application, these are always the things you should be asking yourself. Okay, so let's go into our do phase. We're going to create a game class and we're going to stub out all the necessary methods and attributes that's going to allow us to define a game loop and start executing that game loop. So let me start by creating the JS file. So let me see here. So I should be in my scripts directory. I am. So here I'm going to create. And since this is going to be a class in itself, I'm going to use a capital or uppercase letter. So game.js. There we go. So now next thing I'm going to do is let's go over here and drag that into my editor. So I can start updating it. And then here, I'm going to take the steps and initially define my class. So I'm going to define a new class using the keyword class. And then I'm going to give this class a name of game using uppercase letter. And then I'm going to give this class scope using curly braces. So far, very similar to Java. Then I'm going to give all my class properties, or what you might refer to as instance variables. So one class property I'm going to give is the isOver. So it's going to be a Boolean variable. Now, JavaScript is not a strongly typed language. So it's more important than ever that you use good variable naming to be an indicator of what each variable is supposed to model or represent. And again, we're going to put hashtags in front of our names because the JavaScript interpreter will treat those as private data and won't allow those to get mutated outside of a class, outside of an instance method. And then underneath the class, in order for me to be able to play around with our source code and whatnot and be able to access it from our HTML document, from our general JavaScript runtime environment, I'm going to create an instance of our game and then bind it to a constant variable called game. And effectively, this allows me to treat it as if it's a singleton object. So I won't have to instantiate it again. Okay, so let me save that up to this point. And so the next step after I've initially defined my game class and the properties inside, I'm going to define the constructor. And the constructor's role is effectively to set up the state of an instance. So after my instance variables, let's go here and define a constructor method. And again, every time, I don't know if I mentioned this on the view class, but let me highlight this here. Every time I want to dereference one of these instance variables that's defined inside of the scope of game, I have to use the this keyword. So the this keyword has to be used. And that's because since JavaScript supports more than an object-oriented paradigm, it's possible that I can have variables that are scoped inside of a function or inside of even the global scope that might also have the name isOver. So to ensure that I'm always referring to a instant scoped variable, I'm forced to be explicit with the this keyword. So whereas Java is more lax in this regard, and you can dereference instance variables without the this keyword, you cannot do that in JavaScript. Anyway, so I'm going to dereference the isOver property, and I'm going to initialize it to false because the game is going to start as not being over. Yeah, that's right. So, but that means that this is more consistent with the C family paradigm or languages. So just like C++, C#, and Java all use this keyword as a reference pointer to the object in memory of itself, so does JavaScript. But JavaScript can be kind of hairy with this keyword, and we're going to see that when we talk about more object-oriented things. In fact, the object-oriented lecture is really going to show you some of the interesting happenstances that can occur with this keyword. Okay. The next thing I'm going to do is our game class is going to manage the state of our game, which means that the state of a game typically, the main game loop has an update phase and it has a render phase. So we're going to create an update method that's going to be responsible for updating our game model between each turn or each round or each tick of the second of the cycle, of the game cycle. So inside our update here, we'll just initially have a console log that just says game update. And again, this is just for testing purposes, so we'll delete this line after we're finished this goal. But to give us just a behavior we can observe. And then what we also want is a render method, because again, the game class will be responsible for updating and rendering. So for initial purposes, I'm just going to stub out this method with a console.log. So console.log is, if it's not apparent already whenever I go into the developer tools, it's what serves as like a system.out.print statement in JavaScript. So if I do console.log hello, it's going to print out hello. So this is one way I can send test messages or console log messages to my terminal for testing purposes. Now, clearly these aren't displayed in the viewport, so this is designed as developer messages and not end user messages. So you would normally do a full application with console.log messages, just like you wouldn't make a real application with system.out.print messages in Java. Okay, so now that we have our update and render methods, the next thing we want to do is actually build our main method, which is going to be the actual launch point of our game application. And so here, if I want a method to be static to the class itself and not an instance method, I can use the keyword static in front of it. Again, all the same paradigms you learned in 1583 and 2120, you can use to design true object-oriented software in JavaScript. So inside of our main method, we're going to open and close scope. We're going to do the following. We're going to check if inside of game is over. So since we're inside the game class, we can access this attribute, right? Because we're inside the class scope. Notice game is an existent object. It's this variable here that we've declared. So if inside of game is over is equal to false, then we will invoke the game's update method, and then we will invoke the game's render method. And then from the window object, that is the global object that is available to us in our JavaScript runtime environment, there is a built-in method in the API that's called request animation frame. This means you can register a method to the window, and it'll get repeatedly called again and again and again. So here we will go ahead and repeatedly call this main method. So if you think about this, it's kind of a recursive call because we're sending from the main method the main method itself. However, it will stop registering this to keep repeatedly invoking the main method once this is over variable is false. So if game over is false, then instead of doing this if statement, we will instead do the else statement, and we will print to the console game over. Okay, so now once we've done that, why don't we go ahead and actually launch our game using the HTML document. So here, let's go into our HTML. Every time we add a new class, we have to import that class into our HTML document because that's how we get our JavaScript files into our JavaScript runtime environment. So here, I'm going to import the game.js file after the view.js file. And then I'm going to create a script tag where I'm going to tell the window object to add an event listener. And when we add an event listener, we can pass it the name of the event that we're going to listen for, and then the action, the callback function that triggers in response to that event. Well, the event we want to listen for inside of our HTML document is when the document loads. So every time a document loads, it actually fires a load event inside the browser. And we can tether the callback function to from our game class to go ahead and invoke that main method. So again, we're not invoking the main method here, right? To invoke a method, we put the parentheses. We're not doing that. We're passing it a reference to the method itself. And since functions, since methods are all objects in of themselves as JavaScript, we can pass them along and save them in memory. So we're going to pass this callback function as a reference, and when the game finishes loading, then we're going to fire this main function. So now let's test this for testing purposes. What we can do is we can open up this platformer.html file on our browser. And then from the dev tools, we'll be able to access the JavaScript console, and we should be able to see it repeatedly show game update and game render, game update, game render, game update, game render. And we should get an infinite number of console logs until we decide to kind of stop that. So let's refresh this page. And yep, there it is. And look, it's just going on forever and ever. Excellent. Okay, let me refresh that. Oh, no. Yeah, that's... Okay, well, let's fix that. That's probably not ideal to have that just going on forever. But we got what we wanted. Is there an interrupt? Let's see. Can I control C? Nope, there's no... I don't think that there is an interrupt. If there is one, I'm not aware of it. I usually just end the terminal. I mean, close the tab when that happens. And maybe I'll do that now. Okay. Okay, so that allows me to move on to my next goal. Now that I've successfully created a game class, and I know my game class is actually launching when I launch my, when I initially open or load my HTML document, and it's triggering my main game loop, and my main game loop is firing the update and render methods back to back to back to back. Let's talk about starting to build a world class to be able to start managing the world data. So again, the approach here is to recognize, okay, we have to define all of the properties that the world class is going to be defined as, and all the behaviors, all the methods it's going to be asked to go ahead and fulfill. And so once I've been able to label those things out, let's actually start building our world.js file. So the first thing I'm going to do here is I'm going to go to build world. And since this is going to be modeled as a class itself, I'm going to use an uppercase letter, world.js. And then I'm going to go here and I'm going to drag this into my IDE. And so I'm going to create a class with a class scope called world and the properties my world is going to require. So just like what I did with view and game, I'm going to do the same thing here. And here, the property that my world is going to have is going to be a collection of levels, right? The array of levels. And again, I'm going to use a hashtag to ensure that that is set as private data so we can get all the same metaphors that we used in Java inside of JavaScript. Once I've created a class and the properties that define my class, I'm going to create a constructor so I can actually instantiate an instance of the world class. And so the constructor inside of my world is going to parse all the map data and save it for later. So I'm going to use some traversal. I'm going to use some higher order functions to traverse my worlds from the data structure that I get from world data. So recall that world data is an array. And so arrays have built-in methods that allow me to do what are called high-order functions. A high-order function, as opposed to a first-class function, a first-class function is a function that you invoke directly and you pass in data into. So for instance, main, let me find something else. Is there, oh, let me go to view. For instance, picture here is a first order, a first class function because it takes data directly and we treat it as a function that gets called directly. Map that we're about to see is what's called a high order function. We pass it another function. So again, if this looks odd to you, if this method looks odd, if this line of code looks odd to you, you're going to have to watch the data structures lecture because I go into much greater detail about what's happening here. But effectively, world is an array. So let me go here. World is an array that we get from world data.js. So inside of my levels property here, so I'm going to dereference the levels property and I'm going to assign to it. By accessing this array, I'm going to map a function on top of it. So this is an arrow function. So you can think of this as an anonymous function. For an anonymous function, this would be the parameters. So for each level that gets passed into here, and it's mapping for every level inside of array, it's going to take the level, it's going to split that level by its new line, by its new line character. So at the end, so let's go back over here into our world data. So each time, since this is a string literal, it maintains all of the syntax, the new line, the spaces, the tabs, all of those kinds of meta formatting instructions that are embedded in the string. It preserves those. So there would be a new line character here. There would be a new line character here. There'd be a new line character here, 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 here. So this anonymous function. Oh, let me go. This anonymous function is going to iterate over each index inside of the world array. So again, the world array has an index of 0, which would be this string. That'd be at index 0. This would be at index 1 and at index 2. So for each one of those indexes, it's going to split that entire index based off of its new line characters to get just each row. And then since each row itself is a collection of characters, I can then map another function on top of that where it's going to look at each row inside the string, and it's going to split it based off of an empty string. So it'll split it into just a set of characters. So this is just a single line instruction that allows us to parse this one string into a two-dimensional array of characters. And again, if this looks confusing, you'll get much better indications of how that works inside the lecture. So please go back and look at the data structure lecture after this, after today, if you haven't done so. So now that we've created this constructor that can parse our data using the built-in traversal tools, the array traversal tools that's built into JavaScript, let's go ahead and update our game class so it can actually have a new property, the world property. So let's go to our game. So our game is not just going to have an isOver property. We're also going to give it this world property inside of the top here where the instance variables are. And then in our constructor, let's go ahead and set that up too, where what we're going to do inside our constructor is we're going to, of game, we're going to go ahead. Yeah. We're going to go ahead and dereference the world attribute, and we're going to assign it a new instance of world. So we'll invoke that world constructor. That world constructor is effectively going to take the world data and parse it into a two-dimensional array. But what we'll do here then is we'll do a console log of our world once we do that, of what we have here. And then the last thing we have to do is, again, every time we create a new JavaScript file, we need to go ahead and import it into our HTML document. Otherwise, it's invisible to all of our other JS scripts. So here, I want to import the world data before any of my other actions in my HTML. Let me put this here towards the front. So here, I'm going to go ahead of it, directly under my canvas element, and I'll just go ahead and import the world data.js and the world. Okay, so all of my scripts that I've made so far are imported, and this was the one that was initially given to me, but now I'm going to start using it. And now to test this out to see if it works, I'm going to open up my platformer.html in my browser again, and I'm going to use DevTools just to access the JavaScript console to see if I'm getting this console log out that's going to produce like this two-dimensional array of characters. So I want to see if I can effectively import and parse my world data. So let's go back over here to my browser, and let me open up the DevTools here. Oh, well, and then here, let me go here to my platformer.js. I'll just drag this into here. Oh. Go to my DevTools, and let me make sure everything is saved. Saved. Okay, let's see here. The ordering can matter because the JavaScript instructions will load in the order that you import them in. So for instance, if my game class required a class, if it went to instantiate a class that wasn't defined yet, it would fail. So do keep that in mind. And that's going to be true for anything that's not essentially packaged into modules. Okay, let me see, make sure I didn't miss anything. So this .world inside my constructor. Oh, you know what I need to do here? I know what I needed to delete those console logs. The console logs are removing. So sometimes what I'll do in a previous step here is I have a cleanup step after testing, remove the console logs. Otherwise, it's just going to keep giving me those infinite console messages, and that's going to be difficult for me to troubleshoot. So here, I even had a comment, delete after finishing that goal, and I didn't do it. So that was me being bad and not following my own directions. So let me delete that and that. Let me save that. And now let me refresh. Okay, perfect. So now I've printed out. So just like in Java, JavaScript has a default toString method. So what's happening here when I'm doing this console.log in the constructor of my game class is I'm going to print out world, and then I'm going to print out an instance of what's in world. And since I didn't define a toString method, it's just going to define one for me, and it actually makes it interactive. So it shows me here that I have this levels attribute, this property, and inside there is a array, a 3-item array, right, for level 0, level 1, and level 2. And then I can unpack that, and I can say this array has 14 elements, and each of these elements has 12 elements, which is the set of characters. Now, if I collapse it here, I can actually see that it actually, with the way that the console is displaying it, I'm actually grabbing the tiles that I can then parse and use to instantiate to build my game objects. So like here, when I see this, I should build a block tile in response to that coordinate, whereas this would be an empty tile. This would effectively be a hazard tile. This would be a hazard tile. This would be where my game character starts at. This would be where the exit is at. So now I'm starting to be able to start parsing my game data in a way that I can start processing it into my model data and starting to build a game around it. And so at this point, I think I'm where I need to be with getting my game at this assessment, right, after goal 4. And I see that I'm out of time. So we're going to stop on goal 4 for today, and we're going to pick back up on the next class, or next time, on goal 5, where we're going to continue this project until we're done building this complete application using a strong object-oriented approach in defining our JavaScript application. So with that said, is there any questions up to this point? And what I would recommend everyone doing, if you haven't done so, is go and watch the JavaScript basics lecture, watch the JavaScript data structures lectures, at your earliest convenience. And it would also behoove you to start watching the JavaScript object-oriented lectures as well. And while you watch those lectures, we'll just continue this process until we're complete. Oh, thank you. I'll have to correct that. I'll have to correct that bug. That says is over. Or maybe I might have that corrected in this version, not that. We'll see. Anyway, I will bid everyone farewell, and I will see you all on Thursday. And if for any reason you have any questions, please let me know in Discord.